fitted into the system. That's how the rule-based system is going to work. So you have here the knowledge base. This is what I'm going to show you when I show the modeling which we did. We had a knowledge base. From that knowledge base, you develop the inference engine, that is the rule-based system. You get the crisp value of input, fuzzify them, take it to the inference system. That brings out the fuzzy value out of the system, which is defuzzified and then comes out as a crisp value. So this is in fact what is happening in case of a fuzzy rule-based system. In a very simplistic way, I have explained this to you. Now, there is another example which you all might have, experienced in your day-to-day life. You go to a hotel and you, at the end of eating the food there, you have to give a tip to the waiter. And you have to take a decision. Kitna tip dena hai. Now, normally, unknowingly, you have already worked with fuzzy rule-based system there. When you decide what tip I have to give to the waiter, you have already applied something what we have just seen here, a rule-based technique. Now, say for example, you decide the tip on two factors. The factors which you decide the tip on are the inputs, input 1 and input 2. First input is the service of the waiter. I would rate it at 1 to 10. So service mujhe diya, I'll rate it as that. And the second input which I would define my tip on is the food quality. So these are the inputs which you decide, and based on that you have some rules in your mind which you already have applied. Like for example, rule 1 may be that if the service is poor or the food is rancid, then the tip is cheap. खाना भी अच्छा नहीं है, service भी अच्छा नहीं है, ज़्यादा tip नहीं देना है मुझे. You may say that the service is good, and tip is average. खाने का छोड़ दो, चलो service अच्छा दिया, tip average tip दे दो. Third rule may be like service भी बहुत बढ़िया था, खाना भी बहुत अच्छा था, अच्छा tip देते हैं, average tip देते हैं. Then these rules are there, and then the rules when they get fired, you sum up the fired rules, and then uske upar based on that you decide the tip to be given. This is what you might have done majority of time when you go to a hotel. Now let's see how the rule base is going to work. The first input was the food quality. Okay, food quality अच्छा होगा तो हम अच्छा tip देंगे. So what you decide is this is the fuzzy set. I have decided based on 0 to 10 में, if I say this is the set, 6 onward, 6 to 10 rating अगर मैं देता हूँ तो खाना अच्छा है. So food, if I give rating 8, food is delicious, I give it rating 8 out of 0 to 10. Then my belongingness would be somewhere around fuzzification. Fuzzified value of 8 would be somewhere around 0.7. Okay, this is the set which I have already defined as a decision maker. I have already defined. We don't actually do this, but I'm trying to explain how the fuzzy system works. Okay, this is what we are doing in day-to-day life. But actually applying the tipping of a waiter, you do something like this. Then you can say that service के बारे में भी मैं बोलूँगा कि service level was 3. तो सर्विस लेवल 3 मेरे लिए ये सेट के ऊपर से 0 जाता है उसके ऊपर. I don't give much tip to that. Okay. So if the service is excellent or food is delicious, then some output result will be coming. So in this case, my service was 3. So output from this is coming as 0. And my food was delicious, as I said. So output was coming as 0.7. The maximum of this 2 goes out to give me some in output from the rule that is fired. So when you apply the or operator or conjunction, that service is excellent or food is delicious, the operator maximum is used, and maximum of these two values, either 0 or 0.7. So maximum goes out as your result in that. So when this rule is fired, when you give service co 3 and food co 8, this rule fired and give you the output of 0.7. Similarly, antecedent and consequence. So when service is 3, food is 8, output was 0.7, which cuts into your tip, generous tip. I say key 5%, 10%, 0%, 200%, 10%, 10% maximum, then I 25%, then I you decide. And based on that, you define a set here, and 0.7 cuts this set at this percent level here. So this is your final output of 0.7. The rule fired that service is 3, food is 8, input 1, input 2. This is going to be the result of the output. So you have an antecedent, you have a consequent, and that gives you the output to one rule fired. So similarly, we had 3 rules there. Initially, when we saw this, 3 rules were there. Out of these 3 rules, when you applied these conditions, the first rule fired, service is poor, food is rancid, then this was the output, or it is connected with or, so maximum comes out everywhere. And this is the output of first fired rule, second fired rule, third fired rule. And finally, when we aggregate them, we get the final set of output as shown in this figure, last figure of aggregation, 0 to 25%. Now this is all fuzzy, and I need to bring out a crisp value of how much tip to be given. And what I do for that is the centroid method, which I used earlier. This is the centroid of this figure, and that centroid of this figure says that my tip should be 16.7%. 16.7%. So, my dear friends, what I'm trying to tell you here is that whatever you're doing to tip the waiter, you are unknowingly passing through all this rule-based system and applying it to the system to give the tip to the waiter. That is your result which comes out of your mind. Now, this same concept can be applied in a fuzzy rule-based system to model any scenario which would be, you would be interested to model in your real life system. So this is the example which I wanted to tell you. So important thing is that we learned through this about defuzzification and fuzzification. Now, with this, understanding, there are a lot of fuzzy applications which has come out in various fields of engineering, the automotive, the consumer, the microwave ovens, and the our electronic appliances, washing machines, vacuum cleaner, clothes dryers, everywhere, air conditioners, emission control devices, fuel control devices, industrial and decision support system. Everywhere you see, fuzzy logic, rule-based system has dominantly come in our real life applications in our day-to-day life appliances. Okay, so this is how the fuzzy logic system works. Now, let me explain to you with this understanding how we can actually apply this fuzzy modeling system. We did get a project which was entitled Development of a Model to Predict Concentration of Radionuclides in the Aquatic System at Kakrapar Atomic Power Station. You all from somebody from Gujarat might be knowing about this. It's an atomic power station. It was project was sponsored by Department of Atomic Energy (DAE), and we completed it in uh, awarded in 2009. In 3 years, we completed this project. It's an interesting project. This is the Kakrapar Atomic Power Station, and here you have the problem. I'll explain to you what is the problem. This is the Kakrapar Atomic Power Station. These are the cooling towers, and the atomic reactor is here. Now, the atomic power station discharges its own wastewater into the environment. Particularly, it is discharging the wastewater into artificial canal. It's a natural canal, not artificial canal, natural canal. It is in fact coming from Kakrapar Weir, which is connected to the Ukai Dam. And this is, in fact, Ukai Dam is based on the Tapi River, which passes through Surat. Okay, so there is a dam there, and from the dam, the water is controlled by the weir, which discharges its water on the left and the right bank of the weir. So two canals, left canal and right canal. So this is the left bank canal, and this is the power station. Now, the power station takes the water for for producing electricity, and that after taking the water, it generates radioactive waste, and in a controlled way, the radioactive waste has to be discharged in a controlled way as liquid waste in this canal. Now, this canal water, here you see there is a Ratania regulator. The canal water flows in this regulator. After that, it is becoming free for public use. Public is not allowed to use this water here. So there has to be a lot of regulatory measures because radioactive waste is being discharged. So the problem was to identify and model that what would be the concentration of the radioactive radionuclides, that is the radioactive elements, when it passes the Ratana regulator. This is almost 2 kilometers from the blowdown. This is the plant blowdown. This is the intake. This is the blowdown where the wastewater is added. And from here, this is 2-kilometer distance. This was the problem. To model the radionuclide waste concentration once released into this canal system and then going out from 2 kilometers being available to public. This was the problem. Now it has a lot of challenges, The challenges were, if we see this is the blowdown, and we have 2 kilometers downwind the Ratania regulator. The uncertainties, there were a lot of uncertainties involved with this problem. Fuzzy logic, let me tell you that fuzzy logic is very useful to you if you are dealing with uncertainty in your problem. If you are dealing with vagueness in your problem. If you are dealing with low data quality in your problem, then those uncertainties, those vagueness can be very well defined by fuzzy logic. So the challenges were the uncertainties in terms of, as I said, it was a natural canal, so the canal boundary was very irregular. There was a lot of water hyacinth growth in the canal, and water hyacinth is a floating plant, and it keeps on getting detached and flows with the stream, and that boundary of the water hyacinth, it keeps on changing. So the flow condition within the canal also is not uniform. It keeps on changing. The blowdown concentration also was also never uniform. It keeps on changing. The flow in the canal also, depending upon the water released from the Kakrapa River, that flow also varied. So these were the lot of uncertainties involved in this case when we wanted to predict the concentration of the radionuclides 2 kilometers downstream. Now, if you go by the conventional method, uh, defining a mathematical model, you get a mathematical model something like this. You have the unsteady state condition, that is the concentration of the radionuclides on the left hand side. You have the dispersion and diffusion taking place here. You have the transport of the pollution, that is the radionuclides, that is the advection. You have the sedimentation, you have the radioactive decay, you have the adsorption, you have the desorption. This is a complex model, and if you want to solve this model numerically, my dear friends, you need a lot of site-specific coefficients. Somewhere around 7 to 8 site-specific coefficients are required to solve this numerically. And I am not very good at mathematics, to tell you frankly. I cannot solve this type of equation even if I am given the uh, coefficients. So for me, this would be a big challenge, that how to solve these problems. Many people are not confident with mathematics. That's fine. Okay, there are various techniques available by which you can solve this type of problems. That's what I'm going to try to show you. This is the actual model, but without going into this complex mathematics, friends, you can predict effectively the concentration of radionuclides 2 kilometers downstream. That's the beauty of the fuzzy logic. That's the beauty of the fuzzy rule-based system. Now, what happens here is that we had a lot of database available, that what we had, like looking around this, what we had on hand was the complete time-based concentration profile. Once the discharge was started, we were interested in tritium concentration. Of course, later on, after tritium, you could apply to any other radionuclide also if the data is available. I am going to show you that the tritium concentration was available. So we worked with that. And when the discharge was started at 2 kilometers, at what time the activity was, radioactive activity was, radioactive activity was detected, that information we had. So we use this fuzzy rule-based approach system to predict the tritium concentration at Tritania regulator, from where the water is available to the public for domestic use. So that's a very very important concern for the authorities to see that the concentration should be always under the limit, because it's a radioactive element. So what we had on hand was the main flow in the left bank canal. The flow was defined with fuzzy set F, and the range of the flow which we had was 0 to 4800 cusacks. That was irrigation data available with us. We had a concentration of tritium which was released from the blowdown point, which we defined as D, and the concentration of tritium released from the bottom point was ranging from 0 to 21,000 becquerel per liter. This is what data we had. And then the output parameters, what we had was the tritium concentration at Ratania, which we defined as fuzzy set CR, and the concentration range there was 0 to 400 becquerel per liter. Okay, so that data, ample amount of data was available with us. So we developed fuzzy sets for each input and output parameters, and fuzzy set of 5, 12, and 12 triangles for F, CB, and CR respectively. So this is how 5 triangles of flow were defined. See, this screen which you are seeing here is the screen of the MATLAB. Dr. Namrata Jariwala will be showing you how to develop this MATLAB fuzzy functions and all that. I'm not going into details of that. I'm simply showing the application part of it. So for flow, I defined 5 flow conditions: F1, F2, F3, F4, and F5. And these values, as I said, you can see here, this was the range 0 to 4800 cusacks. This is what it is. 0 to 4800 cusacks was the flow. And I defined it in different 5 sets: flow F1, F2, F3, F4, and F5. Okay. Then I had discharge. I divided that discharge value, which I showed to you earlier, 0 to 21,000 discharge value becquerels per liter, into 12 sets. You can see I have divided these sets in such a way that some of these sets are nearer to each other, and some of these sets are equally spaced on the other values here. Now this means that my discharge mainly lies in this area. So I have made finer triangles in this area here, and this rarely happens. So I have equally placed them to give me some idea how the concentration would prevail. And then 12 sets of the output at the Ratania regulator, 12, dividing as output 1, 2, 3, 4, 12. This was divided as CB 1, 2, 3, 4 up to 12. So this was the second input. As I told you, it is up to the decision maker to define these triangles. You can make your own system. That does not matter. And this was the output. So 2 input variables and 1 output. Now imagine, friends, when I told you that I showed you that complex equation where I wanted to solve that equation, 7 different coefficients. But I am now working with only 2 variables which were available to me to effectively predict the concentration of tritium concentration at Ratania regulator. Just 2 inputs and 1 output. Concentration at Ratania regulator. And you can compare now that how simple this system becomes when we apply fuzzy logic. All that uncertainty related to that coefficients to be applied to the mathematical equation vanishes. I don't need those things here. That is the logic here. And then based on that triangular membership, which I had 5, 12, 12 for flow and the blow down and the output concentration, the MATLAB finally you give the MATLAB conditions here: 2 input. This you see here, yellow boxes, 2 inputs and 1 output. And when you do that, you frame the rules using the MATLAB functions. 2 inputs, 1 output. There were 720 rules which were formed. Just as I told you, we started understanding this with 4 or 5 rules, but when we actually apply this rule-based system, to your problem, the rules may be 700, 800, 80, 90, whatever. So logically, what has happened is that the MATLAB has picked up each of 111 of this 5, 12 and 12 sets and framed 720 rules. But now comes the system which we defined as the knowledge-based lookup table. What is this knowledge-based lookup table? Now, 720 rules, friends, I don't need certain rules because those conditions never happen in my scenario. So I will be eliminating all the rules. See, mathematically, computer ने तो क्या किया? जो मैंने input दिया, उसके सब rules बना दिए. It made 720 rules. It's simply following the instructions, simply made 720 rules. But my knowledge base says that certain rules are not required because those conditions never happened there. So let me explain to you. Now, these are the flows which are on the left-hand side vertical column. Flows 1, 2, 3, 4, 5 different flow conditions as per that 5 triangles. The second input is my discharge. 1 to 12 discharge conditions I have there. And if flow is 1, discharge is 1, ये condition कभी होता ही नहीं है, इसलिए मुझे यहाँ I did not get any concentration at Ratania regulator. You see, these values which you see in this matrix inside, these are the concentration set. Concentration set I made of how many triangles? 12 triangles. So I have the triangle number where the concentration lies based on the condition of discharge and flow. That means if flow is F3, my rule says if flow is F3 and discharge is D5, output is 3 and 4. So you will say, why 2 outputs? Output 3 happened only for 4 times. I got concentration 3, set 3 for 4 times and concentration 4 for 10 times. This is what my data shows. So what I'll do is I'll pick up the data which has the maximum value here, 4. So when F3 is the flow, D5 is the discharge, then my output is 4. So likewise, you see here, I get a lot of information that which rules are useful to me. So I would eliminate the rules which says that discharge is F3 and, the flow is F3 and discharge is D10. I would eliminate that rule because that rule does not apply. That condition never happens. Similarly, all those blanks I would eliminate. I would eliminate where 2 values are there. Where 2 values are there, here 7, the 4 and 11, I would pick up 6. I would eliminate this rule that F3, D8, 7. I would eliminate that rule. So when you have the knowledge base available with you, you prepare the analysis of the knowledge base based on such sheet, and lookup table was prepared and rules were eliminated. And when out of that 720 rules, lot of rules were eliminated, 38 rules were only required and remained, which give me the prediction of the tritium concentration. So remember one thing, when you are working with the rule base, when you are working with the mathematical tools like MATLAB, you need to be very cautious as to what rules need to be applied and what rules to be eliminated. So we now have only 38 rules with us. And with these 38 rules, we predicted the output. and the predicted and measured, computed and the predicted values which are there uh, are shown in this scatter diagram. You can see that the scatter plot lies very near to the best fit line that gives you the exact predicted and computed values. So by applying this rule base without going into any, uh, what you can say, mathematical equation, we solved this problem and predicted the concentration of Pratania regulator 2 kilometers downstream without applying any mathematical equation, simply by applying fuzzy logic application. You can work with this type of fuzzy rule-based system and uh, apply it to any problem that you have in your mind. So I can conclude by saying that fuzzy rule-based applications can give good solution to various engineering problems without entering into the complexities of mathematics. Many may not be, expert in mathematics. Of course, later on, recently we did, one of the students got a PhD when she worked with this problem of Kakrapar atomic power station. Later on, we were awarded a second project by Department of Atomic Energy, where the near field concentration of tritium was to be modeled. The same canal was there, the same blowdown conditions and all was given to us, and the near field, that is around 200 meters distance, 200 300 meters distance at various locations, what would be the concentration of tritium that was required to be measured. So we did that in two parts. That's a thesis which has been submitted. That lady also would soon be getting her PhD. Both the reports have come positive. So one application was using actual mathematical modeling through Fluent software, and second application was again applied by this type of rule-based system, where the whole rule base was prepared, and depending upon the blowdown release, set of rules would be extracted from the master program, and that set of rules will form the rule base, because your blowdown concentration is also not uniform. It keeps on varying day to day. It keeps on varying. So depending on what the authorities are trying to, discharge, the program extracts a set of conditions as applicable to a particular day and forms the rule base. That was the second part of the second project, where the student will be getting a PhD soon. So this is what the fuzzy rule base and its application is all about. So thank you very much for listening out to me patiently. And if you have any questions, I would be happy to take that.
Thank you so much, sir, for the lucid explanations of all the basics and using day-to-day examples for clear understanding. It definitely was an engaging session. There are some questions in the chat box, which, with your permission, I would like to ask you on the behalf. Yes, Shobhana Purushottam wants to know that this rule-based grouping can be done by basic programming itself. Is there any specific reason for using fuzzy logic for this application?
See, fuzzy logic basically it deals with lot of uncertainty in the data. So if your data is having uncertainty, then fuzzy logic and fuzzy set theory as a tool is the appropriate technique which you can use to model the system. As you can see, what I showed in my project, that in spite of having so many uncertainties and the rule base and the fuzzy logic system, we could predict very fairly nearer to the actual values. That is what could be done. Of course,
Okay.
fuzzy logic is one of the tool, as I said. I don't say that it's the only tool, but it's simple. Using the MATLAB technique and all that application, you can very easily apply this and accept it. Fuzzy logic as a uncertainty addressing tool is very easily accepted also.
Thank you, sir. Laren Satapathy wants you to give an example of fuzzy rule-based system with application in particularly, I guess he wants a structural engineering example. If you can help in
See,
her with.
I am not an expert on structural engineering as such, but structural fault finding and a lot of other things. People have applied the fuzzy logic, and particularly structural people do a lot of analysis to assess the risk of the structure. So there are risk assessment technologies using fuzzy logic, so that also is another area where fuzzy logic can be very effectively applied in that case. I know of Dr. Sudhir Barai. He's a structural engineer. He Bits Pilani may be his director. He is basically from IIT Kharagpur, a good friend of mine with structural background. He is working a lot with fuzzy logic in structural engineering. I think she can get in touch with Dr. Sudhir Barai, and he can help you more in that. But whatever may be the system, structural engineering, water resources, transportation, whatever may be the system, what you basically need is a set of inputs and a set of outputs.
Okay, sir.
You have the data on that, you frame any rules, and you get the output. When you want to predict something, like for example, the health of a structure or whatsoever, you give the inputs on the quality of the beams and the columns and all that in that linguistic terms. You define the sets in the linguistic terms, and then try to give a single output, whether the building is safe, unsafe, or strong. You give the outputs in the linguistic terms.
Okay, sir.
I don't know whether
Thank
that
you so
the
much.
person.
Okay, sir. Thank you so much, sir. Muhammad Yasin Bhatt, he is commenting that you are the coolest professor that he has come across in a while.
Thank you, Mohammed. Thank you
And
so much.
he has a question that is there any relation between fuzzy set theory and quantum bits? So if you can guide him a bit on that.
I am not an expert on quantum bits, so I don't know how I would be able to, because, I started and I studied fuzzy logic in that was in 89 or so.
Okay.
I listened to my first lecture on fuzzy logic uh, in South somewhere in 89. And then I started applying it gradually to a lot of environmental engineering problems. Sorry, Mohammed, I am not able to justify you with my answer because I am not expert on quantum based. But I think if you go deep into fuzzy logic, you may be able to find that answer.
Okay, so thank you so much. Udyan Srivastav wants to know how close relative are fuzzy logic and Boolean algebra.
See, again, these are a lot of questions coming where My expertise is not there, and I have not really explored to that extent, like applying Boolean logic or something like that. But if if the person who is asking the question can elaborate something on that, I can share some light on it.
Okay, Udayan, if you're listening, can you please
Elaborate on that. What you
elaborate a bit
exactly
on
want to
that?
know?
What you want to know? Okay. Uh,
Is not there?
I don't think he's there. We can just wait for a bit if possible. Okay, Mohammad Yasin Bhatt is himself explaining that quantum bits specify
Okay, yeah,
values.
fine, Mohammed, go ahead.
Okay, he's explaining that quantum bits specify values from 0 to 1 instead of usual binary values 0 and 1. So he thought there must be some relation, but it's fine. He's saying it's
No,
fine.
Muhammad, I think in many of that type of probabilistic approach and all that, you need to have 0 and 1 whenever you are quantifying that values. The summation should be 1. Many times it is like that. Here that is not so. And the summation of this fuzzy numbers need not be 1. It can be anywhere like between 0 to 1.
Okay.
I don't know if I am able to justify something on that part of it.
Udayan has responded. He's saying that fuzzy logic seems close to logic gates. So if you are they somewhere related? Udayan, you can speak to sir directly if you want to.
Yeah, please, Udayan. Hello.
Hello, Udayan. Just a second, sir.
Udayan, please. If you can.
Okay, he's asking for a second. I think he will. He would like to chat with you personally, I guess. Okay, Udayan, we are waiting. Meanwhile, many are commenting that your presentation was extremely nice and very interesting and engaging, sir. Thank you so much for the efforts and
Thank you all. Thank you all.
the audience.
And in fact, I have presented very elementary part of the fuzzy logic, but there are lots and lots. You can go into the depth to explore the depths of fuzzy logic to apply it to your problem, whatever it may be of any field of engineering. Of course, Dr. Namrata, she completed her PhD under me. We predicted the health of solid waste workers using fuzzy logic system, and then that was validated with the real-time data. So that's another application which she sharing with you on that regard. So you will get a good exposure there also, that how it can be applied to your problems.
Also, sir, the people want you to share your presentation with them. So, if you can share your presentation with Dr. Dar so that we can share it with the participants also. So, it will be there with them whenever they want to revise the basics. They can go there.
What I'll do is I'll remove that KAPS wala part of it because it's a project related thing.
Sure.
That there. So, apart from that, I'll be able to share with no problem.
Thank you, sir. Yeah. Udayan, you can speak now, please.
Okay. Sir, very good morning to you.
Yeah, good morning.
Sir, the fuzzy logic seems a little close to like logic gates. So it had like 0 and 1 output in the case. So is that related some like?
See, I don't know what you are related to what?
Sir, logic gates.
Logic gate. I don't know, but the fuzzy sets, more or less they are overlapping each other. fuzzy sets which we prepare, they compulsorily have to overlap. So the belongingness of a particular linguistic variable overlappingly lies in two sets, and that gives out the value that gives in the fuzziness to the system, because it is lying in two sets. I don't know what other system you are referring to, if they have that sort of overlapping systems or not. 0 to 1 may be there, but when we talk of fuzzy sets, they are always overlapping each other. So that's where the fuzziness comes in. A group of tall people and short people. So short people may fall in a group of tall people to a certain extent, but the belongingness of the short people in tall will be less. So everybody is member of all sets with belongingness 0 or 1. That's the beauty of the fuzzy sets, and it's always overlapping. There are interesting cases where Professor Ashok Deshpande, you can search out his work. He was said to be Lofty-Zadeh of India. He expired just 5-6 months back. But he has done a lot of work where he has developed a new technique where the fuzzy sets and the actual sets, they are measured by overlapping technique. Ashok Deshpande. And then with degree of certainty, they have come out with result that the temperature is very hot with degree of certainty 90, or temperature is very cold. He worked on the Ganga river purification system assessment. So how pure has Ganga become because of the tools which have been applied? He worked on that. You can find out his papers on fuzzy logic. Ashok Deshpande.
Thank you so much, sir. I got my answer.
Okay, thank you.
Thank you so much, sir. There aren't any more questions. I guess everything is clear. And thank you so much, sir, for answering all the questions so politely. We would like to express our deep gratitude for your time and generous support. Hopefully, we'll be having many more sessions with you in future as well. Thank you so much for your time and efforts once again. And
thank you. Thank you so much, Shikha. Shikha, isn't it? No?
Sakiba.
Pardon?
It's Sakiba. Sakiba it is.
Sakiba. Okay. Sakiba. Oh, आंखें अभी fuzzy हो गई है ना.
It's fine. It's fine.
Okay.
Thank you so much,
Sakiba,
sir.
thank you so much.
Thank you, sir.
And,
yeah.
Definitely, if any of the other participants, they have my email ID. And if they want any other information, they can write to me directly. I will be able to help them out in whatever way possible, along with my other colleagues who are working in this area at SVNIT. Thank you so much, all of you, for
thank you, sir. Thank you so much. Thank you once again, sir. Thank you so much. And all the participants, we have another session at 11:30 by Dr. Pranamesh Chakrabarti on CNN. He will particularly talk about CNN in transportation and engineering. So please be available at 11:30. We will start the session sharp at 11:30. And the people who are asking for sharing the mail of sir, as in Dr. R.A. Christian, we will send the mail ID to your mails along with all the other things that we do every day. Okay, thank you so much.
Thank you all.